Hey, you 11s! Hey, guys. Rue's first in the class, first in the chat. It's like, boom, I'm in. Right, okay, guys, quick lesson today. Let's crack on. We've got Equilibrium Lesson 5, Concentration and Catalysts, and this, guys, apart from having an overall review of this, well, I will do that. I will do like a lesson purely based on exam questions from GCSE, all the different types, and how it draws on each lesson that we've got in the 5-lesson sequence. But otherwise, guys, we're drawing equilibrium to a close, which is great. I will do a little bit on industrial equilibriums for you to learn. And the Haber is the main one, Haber and the direct hydration of ethene. So I'll do those two in a lesson. So we've got this lesson, industrial equilibrium, and then summary, and then test. So guys, in 3 lessons time, you're going to be coming up for your test. So make sure you're having a look at the support sheet, doing the booklets. Okay? Right. Okay, let's share our screens. It's nice to give you a heads up that in about a week, you'll be doing your test, give or take. Right, we're in. So today's a nice and easy lesson because it's a continuation of the previous ones that we've been doing. We've been practicing KOFSY. We've seen KOFSY. We know that in equilibriums, we talk about the change in temp. Yeah. And we can run KOFSY on that. Yeah, KOFSY. Yeah, we can run KOFSY on that. The key one is the knowledge. Thought reaction is endo or exothermic, depending which one it is. We can do a change in pressure, and we can do KOFSY for that. And this is the most important bit, the number of particles per on each side of the equation. Yeah, and the last one we're now doing is change in concentration. So that's today's lesson. So the first thing I want to do is apply KOFSY to concentration. So let's grab an equilibrium. So, and let's start picking up some of our industrial ones. We can rope them in. So we're going to take ethene. We're going to take ethene. I wonder if how many of you guys are all remembering your organics. Oh, do you miss it? I love organics. It's like my bag. It's my bag, baby. So we've got ethene. Yeah, ene because of the double bond, and steam. Yeah, it's a gas. There we go. Ethene gas, steam gas in equilibrium, and I am going to make our Friday night molecule. We're going to make ethanol. Woo! There we go. So we're taking ethene gas, an alkene. We're reacting it with steam, with water vapor, and we're going to produce ethanol gas. That's the equation. Let's, by the way, turn it from displayed. Let's chop it out of displayed and into structural because it's easier to see. CH2 plus H2O in equilibrium to CH3, CH2OH. Yeah, okay, and the equation, what you'll notice is it's already balanced. 1 to 1 to 1. Right, and these are all gases. Okay, so what we're now going to do is we're going to apply concentration. So we're going to ask a question. So question number 1. So I'm going to ask, let's go for Ben since he was the last person on the chat. Ben, which person in the equation would you like to alter? And do you want to increase its concentration or would you like to decrease its concentration? Choose somebody and give me an increase or decrease of that person. What would you like, Ben? So Ben, ... What is Ben about to do? I'm going to shrink my pen. I can't read it very well. Ben, ... What's he going to do? Ethene increase. Love it. Thanks, Ben. Love it. So Ben increases the concentration of ethene. What happens? Explain change in yield of ethanol. Right. Okay, so what I always say to students, you should never, ever, in equilibrium, you should never jump Chinese superstitions. I'm so confused what's going on there. No, please don't write my name in red. It's bad. Oh. Sure, Ben. Always done, fixed. So Ben increases the concentration. They can explain the yield. They explain the change in yield of ethanol. Okay, so we're going to run KOFSY. That's what we're going to do. KOFSY. KOFSY. So, and the hardest one is the knowledge. Yeah, we're starting to get used to this process now. Yeah, we're running this. I'm going to change my color. So knowledge. So the knowledge part of this is who Ben has increased. Ben has increased ethene, and ethene is a reactant. There's my knowledge. Ethene, knowledge. Ethene is a reactant. That's it. That's all you need to state. Yeah, is a reactant. Right, oppose. Oh, this is the easy one. It's the one that everyone loses, but it's the easy one. Yeah. So what did Ben do? Ben increased. It's in purple, Ben. Don't worry. Ben increased ethene concentration. Now, what's the equilibrium going to do? Concentration. So what's the equilibrium going to do? So equilibrium will reduce. It's going to do the exact, it's going to decrease. It's going to be the exact opposite. Decrease ethene concentration. Ethene conc. Upper concentration. It's going to decrease it. If he raised it, it's going to do the opposite. I feel like I'm running off. I want to make this fit the page. Concentration. I'll just move then. Concentration. There we go. And I'm going to move the F. There we go. Swing that down there. So now I go, right, favor. How is it going to decrease ethene? Oh, hang on a sec. In order to get rid of ethene, it's going to go away from it. So it's going to favor the forward reaction. Yeah, it's going to decrease the concentration of ethene by favoring the forward reaction. The forward reaction turns ethene into ethanol, and it's trying to get rid of it. So it's going to push it that way by favoring the forward reaction. Next, right, so we add this and it goes that way. Yeah, it's a reactant. It's going to then, you've increased it, it's going to decrease it, and it's going to do that by favoring the forward reaction. This is the left, and this is the right. So now we get our shift. So by favoring the forward reaction, the equilibrium shifts. S is shift. Oh, why is it suddenly shrunk in size? Weird. Oh, it's because I've chosen a different thing, isn't it? Shifting left to right. Shifting left to right. And the yield, KOFSY. Oh, KOFSY. Oh, therefore, what's going to happen to my yield if I'm shifting to the right? Ben, what's going to happen to the yield of ethanol, please? Of course it does. Thank you so much, Ben. He's on it. So the yield increases. Yield of ethanol increases. Right. Now, this time, so cool, guys. We can run KOFSY on all of them now. Whoop, whoop. We're done. But it's all about the practice. You know, this is a process. We've got to make sure that we embed it. Yeah. Shan. I'm going to ask you a really hard question, Shan. So, Haber process. Shan, are you ready? N2 plus H2 goes to NH3. Balance it. Cool. Okay, we're all balanced. Balanced and good to go. Right. So, what we now realize is that we can do some clever, fun things with this. I'm suddenly realizing that Shan and I have paused the video. So what we're going to do is, let's do No, not particularly, but okay. So, Shan, you asked me last lesson on the chat, you asked me, oh, can you give me a scenario where the equilibrium, instead of going to the right and increasing the yield of the product, could you give me a scenario where it decreases it? Yes? So here's my challenge question to you, Shan. So looking at this equation, in terms of concentration, Shan, so we're looking at this from a concentration perspective, yeah? If I wanted to make less ammonia, what would I do to the concentration of somebody here? I don't mind who you pick, just as long as you pick the right decision on whether to increase it or decrease it. I wonder if you can tell me that. So, Shan, I want you to pick someone in the equation. You can pick it randomly if you like. Pick someone, and I want you to tell me what to do to that chosen substance to shift the equilibrium to the left. What do you want to choose? And what do you want to do with it? Increase or decrease? It's hard, isn't it? Because essentially what you're having to do is run KOFSY in your head. After a while, this actually becomes, you pick up pace, but it is a development process. Being able now to think, hang on a sec, it's not just a random decision now. I want to skew this in a particular direction. Who am I going to pick and what am I going to do to them? Just want to give Shan a little bit of time. I hope everyone in the class right now is considering that question, is thinking to themselves, well, okay, I can pick out, in reality, I can shift an equilibrium using anyone. It's just what I'm doing with that person I've chosen. Okay, decrease H2. Let's run it, Shan. Thank you so much. Let's run it. Shan has chosen. Shan has spoken. Sorry, what? Question. Shan, what did you say? Decrease H2, but I'm not really sure. And this is what KOFSY is awesome for Shan, because we're about to find out. Shan decreases the concentration of H2. Explain yield change of ammonia. I like it. Cool. It's a great choice, Shan. Loving it. Cool. So let's run it. KOFSY. Knowledge. Right. Shan chose hydrogen. Hydrogen is a reactant. First point. Hydrogen is a reactant. You realize that each KOFSY has a different start. Yeah, each one. Yeah. Oh, Shan, do you feel like that was you put? Oh, okay, I get it now. That's cool. Have you had like a moment of an epiphany? Sorry, I spoke to Tiffany the other day, and I realized that I could say epiphany instead of epiphany. Sorry, I'll shut up now. Have you had an epiphany? Is it like penny dropped, fog clears? Yeah, sorry, I'll continue. Hydrogen is a reactant. Right, what did she do? Oppose. Shan, go back to purple. Yeah, Shan decreased concentration of hydrogen. So equilibrium will increase concentration of hydrogen. I know it's a faff, sort of. Love it, Shan. Love it. Next, favor. So how is an equilibrium? How is the equilibrium going to increase concentration of hydrogen? It's going to go that way. It's going to go the back. It's going to favor the reverse, the backward reaction. That's the way to make hydrogen, and it's trying to increase it. So the equilibrium will favor the backward reaction. The backward reaction. Right, so if it favors the backward reaction, it shifts from right to left. shift. Equilibrium will shift. Will shift from right to left. Love it. What's going to happen to the yield, Chan? Mr. Duncan, how do we know what to write for K? Tong, by practicing. There's only 3. I'll come to that in a second. Shan, now that we've discussed this, what's going to happen to the yield of ammonia, Shan? I'm going to come to Tong's question in a second, folks. Yield decrease. Well done, Shan. You did exactly what I asked for. You did brilliantly. Well done. Yeah. Well done. Spot on. I like it. Okay, so just to help Tong out, KOFSY is a great process. And the one thing we identify that for each of these changes, it's the K that is the tough bit. That first bit of information. Yeah. So what it's worthwhile doing is temperature. We've now run KOFSY for all of them. It's just nice to put in another thing and say what the knowledge is. Yeah. So the knowledge for temperature is endo/exo forward reaction. Forward reaction. Yeah. You have to choose it based on the equation. An example. There we go. So I give you that, and as soon as you see that, and they say temperature, you see this symbol here and go, it's exothermic in the forward direction. Yeah, that's the example. I'll move that next door. Yeah. So it's worthwhile writing down this little block table. Yeah. And this is the example. So the knowledge always comes from the equation. And in this case, for temperature, it's him. I'm going to underline it in a different color, I think. Yeah. And in reality, just that symbol there. Don't even care about the number. Yeah. If you have pressure, if you have the pressure, it is moles of gas on left and right. Example, black. Suddenly realized. Here we go. Moles of gas. Nope. Stuff that up. Shouldn't do that. Should never try and learn equations, you build them. Sorry about that. There we go. So the example here is on this side, there are 4 moles of gas, 3 and 1. And on this side, there's only 2 moles of gas because of that. Yeah? I hope this is helping, Tong. I hope this is helping. Yeah? Next one, concentration. The knowledge bullet point is going to be reactant. X is a reactant / product. Yeah. So depending on what you're choosing. Yeah. So the example would be ethene. I've given you all 3 industrials that you need to know. Isn't that beautiful? Beautiful. Amazing chemistry. Love chemistry. It's beautiful. Right. And this is a gas, and this is a gas, and this is a gas. So if we pick someone, steam, yeah, we're going to change him. Yeah, change steam. So if we change him, what I would say is, the example is H2O is a reactant. Yes, that would be my knowledge. Steam is a reactant. So Do you know what, Tom? I've never actually done like a summary thing like that before, the K's for KOFSY. I should actually do a K for kick-ass as well, summary like that. It's a really nice thing to do. Change, I'm just going to put reactant down there. Yeah, just to get a bit of feedback off the classroom. Is that helpful for everyone? Okay, guys, so last bit. Catalysts have no effect on the position of equilibrium, so why do we add them? Right. Subtitle: Catalysts and equilibriums. Fab. I'm glad you found it useful, guys. Catalysts and equilibriums. So, facts. Number one, a catalyst has no effect on the yield stroke position, because they're the same thing. Position have no effect on the yield stroke position of equilibria. Equilibriums, on any equilibrium. So the question is, why? Why? Question mark. The reason is that they increase a catalyst increases both the forward and backward reactions equally. So just to try and explain to you why that happens, the reason being is when I was teaching you guys kick-ass, yeah, when we were doing kick-ass and rates, don't write this down. When we were doing rates, one of the things I talked about was this idea, yeah, of, in fact, we could do it like this, an exothermic reaction. And we're going to put, let's lob Tong on the mountain. Hi, Tong. Tong's going to go for a walk. Whoa, that's a big eye. Holy moly. Tong's going to go for a walk. Yeah, she's going to, and we realize that she's got to climb a mountain. Yeah, this is the climb she's going to make. And we know that the height of the hump is the activation energy. Yeah, this is EA. Yeah, so we know that that's going to be a huge amount of effort. So what we could do is we could add a catalyst. Now, what the catalyst cannot do is it cannot lower the height of the hump. It cannot do that. Nobody can change the activation energy of a reaction. But what we can do is provide an alternative direction. And the alternative direction is to take the tunnel. Yeah, we've got a tunnel which is going to open up on the other side. So instead of her having to climb all the way, yeah, she's just going to go straight through the tunnel and pop out the other side over there. Yeah, so she takes a completely separate pathway. Yeah, she takes a completely separate pathway with a lower activation energy. You've got to say with a, yeah, activation energy catalyst, completely separate pathway. Yeah, it's a different path. However, if this is reversible, if Tong can walk both ways, where would she go to go back? She's not going to climb the mountain, is she? She's going to go back through the tunnel again in the other direction. So it actually speeds up the direction of the forward and backwards reactions equally. Does that make sense, guys? Yeah? Give me a shout on the chat if that makes sense. It increases the rate. So the next question is, if it has no effect on the yield or the position, why would we ever add a catalyst? So fact number two. Fact number two. A catalyst reduces the time taken to reach equilibrium. Right, so let me explain that to you. Do you remember a couple of lessons ago, when we first started talking about equilibriums? Yeah, when we first started talking to them, I gave you this scenario. And I said to you, so when we did this, we said, we started off with whites and we're going to turn into red and blues. Oh no, gone, Yorkshire. So started off with 10 whites. And then we went from white to red and blue. And we started off with 10 whites and no reds and no blues. Then, after 1 minute of the reaction, went down from reactants, whites went down to 9, red, blue went up to 101. At this point, what we then realized was equilibrium was established at minute 3. What that means is that was actually a really good amount of time, like 3 minutes. It's nothing. That's great. But if I added a catalyst, that wouldn't have taken 3 minutes. It would have taken, let's say, 1 minute. And so I can run the process 3 times and make 3 times as much. It shortens the time taken. It increases the rate of the reaction. Yeah, so it takes less time for it to reach the equilibrium position. So it's nice to use things that we had in the previous lesson to be able to make the point there. So we can kind of, I'm going to make a mess of this. No cat. With cat. Let's go. Let's try A, B. I shouldn't do that. It's just easier. Just go to A. We're going to go from A to B. Let's keep it simple. Yeah. Going to go from A to B. But we know this is going to be reversible. Yeah. Right, so at the start of the reaction, I'm going to add 10 A's and I have 0 B's. Yeah, I'm going to hit go. Boom, the reaction starts. We're going to start with 10 A's and 0 B's, same numbers. Yeah, I hit go. Here's what happens. Yeah, at minute 1 minute into the reaction. Yeah. I'm going to get to 9. The reaction here slows down. And the backward reaction starts. And I've now got 1. In minute 1 over here. Minute 1, we go to 8. And we've now got that situation, 2. Yeah, at minute 2 on this one. At minute 2, we've got 8, and it'd actually be exactly the same as the one on that. So what I should have done is tried to keep them all exactly the same so you could see the play out in terms of the scenario. But there's an in-between one for that one. There we go. And then, so this one now becomes 8 and 2. At minute 2 over here, at minute 2, we end up with 6 and that's gone down by 4. That's going to increase by 4. There we go. Yeah, there we go. So that one has now reached equilibrium. Yeah. But this one now takes minute 3. It's going to be 7 and 3. And then minute 4, 6. And now we get to the same position there. So with a catalyst and with that, we just get to shorten the time. That's all that's happening here. And of course, what that means is I would now, once I attain equilibrium, once equilibrium has been established, no more changes is going to happen. 4 is my fixed product. I have the same yield. Yeah, I have the same yield. But I did it in half the time. So now what I'm going to do is I'm going to take out that 4 and start again and make another 4 in 2 minutes. So overall, overall, with a catalyst, I'll make twice as much because I will run the process twice in the same amount of time. And that brings me to the end of my lesson for today. Tick and tick, learning objectives. We know it has no effect on the position and we can explain it. So why do we add a catalyst? We now understand that one too. That brings me to the end of my lesson. That guy, right, we're back. Right, guys, I hope you found it useful. Now, guys, now that we've finished KOFSY for all three, I'm going to post your homework, which is your exam style questions on equilibriums. It has all three, the worksheet has got all three on it: temperature, pressure, and concentration. Each one is in a relatively unusual setting, to be fair, but just run KOFSY and you'll be absolutely fine. I just now need to embed this, really get this well practiced, get it learned, get it established. Yeah. So guys, have a nice rest of your day and I will see you very soon. Take care. Bye guys.